This problem gives us a function y equals 7x minus 2x squared. And I've drawn the function on the right. And it also tells us that there's a line that's going to go through this region that is below the curve and above the x-axis. And that line that we're going to draw, it's a straight line, is supposed to cut that region below the curve and above the x-axis into two equal parts. I'm going to go on and shade the region that we're talking about. So this is the shaded region, and the red line that I've just drawn takes that region and it splits it into two equal parts. So the first thing that we're going to do is we're going to need to find the area of that region. But before I do that, I'm going to need to know what the limits of integration are. I know that this point right here is the origin. So we know that that's the point 0, 0. This point I'm not sure of, but that's okay, because notice that these are just the x-intercepts. The points here, the point 0, 0 is an x-intercept of the curve, and this other point is the other x-intercept of the curve. So we know how to find x-intercepts. So let's go on the x-intercepts. Remember, you're going to let y equal to 0. So 0 equals 7x minus 2x squared. And I'm going to solve this by factoring out an x. 7 minus 2x equals 0. X equals 0, or 7 minus 2x equals 0. And if 7x minus 2x, 7 minus 2x equals 0, that means that x has to be equal to 7/2. So our 2 points of intersection at the x-axis will be the point 0, 0 and the point 7/2, 0. Okay, so these x values are 0 and 7/2. Okay, so now I know what my limits of integration are. So the area is equal to the definite integral as x goes from 0 to 7/2 of 7x minus 2x squared dx. And we're going to find the definite integral, or evaluate this definite integral. To integrate or find the antiderivative of 7x, we get 7x squared over 2 minus the antiderivative of 2x squared is 2x cubed over 3. And we are evaluating this from 0 to 7/2. Of course, this means that we're going to plug 7/2 into the function or the expression for x. So 7 over 2 times 7 over 2 squared minus 2/3 times 7 over 2 to the 3rd power. Just for your information, don't forget you're also supposed to plug in your lower limit of integration. But notice when I plug 0 in for x in this expression, both terms go to 0. So I'll just put that there for emphasis, but that is equal to 0. But multiplying all of this out, and I'll leave this to you to do for an exercise. Once you pull everything together, you should end up getting the area to be 343 divided by 24. So that gives us the area of the region shaded in green. Now let's look at the line. Remember, the line divides that shaded area in half. Okay? But we need a bit more information about this line. Well, I know that it intersects the graph of the function right there. I don't know what that point is, so I'm going to call that x value a. And so I know that this is the point a, f of a. Okay? And so I have 2 points on this line. Of course, I do not know what a is, and so that's really going to be the focus of what we're going to be doing to make this work. But I do know that I have 2 points here, a, f of a, and the point 0, 0. So the slope of the line that we're trying to get, you know the slope, you subtract the y coordinates and divide that by the x coordinate, the difference of the x coordinates. So f of a minus 0 is going to be in the numerator. Well, f of a minus 0 is just f of a over a minus 0, which is going to be a. F of a is 7a minus 2a squared, and then over a. And dividing both terms in the numerator by a in the denominator, we get 7 minus 2a. So this expression gives us the slope of the line, which is what we're looking for. The only problem is we now need to figure out what a is. So the question is, how will we do that? Well, let's see. I'm going to, what I'd like to do is find the area between the curve y equals 7x minus 2x squared and that red line. Okay? So I pretty much want to find this area that I'm coloring in blue. In order for me to do that, I need to have some type of expression that's going to give me the equation of the line. Well, that's easy to do, because to find the equation of a line, all I need is the slope of the line, and I need a point. And I have a point on the line. The point is 0, 0. And I have the slope. It's written in terms of a, but, you know, and eventually we're going to have to figure out what a is. So the equation of the line is y equals the slope times x. And I know this because, remember, we could use point slope formula, but since we know that the line goes to the origin, it would be y minus 0, which is just y. And then in parentheses, you'll have x minus 0, which is just x. So it works out where the equation of the line is equal to 7 minus 2a, and that quantity times x. So if I want to find the area of the shaded region in blue, I'm going to have to find a definite integral again. Okay, so let me write this in blue. Definite integral going from 0 to a this time. And the top function, which is going to be the parabola, 7x minus 2x squared, minus, I'm going to put that in parentheses, the line, which is 7 minus 2a times x. When you multiply all of this out, or distribute and do all that you have to do, simplify what's in brackets, goes from 0 to a, and you're going to be left with negative 2x squared plus 2ax dx. Taking the antiderivative of each term, remember a is just a constant, so we're just going to treat it as if it's a regular number. The antiderivative is going to be negative 2x cubed over 3 plus 2ax squared over 2, and we're evaluating this between 0 and a. We know that we're supposed to plug in our upper limit first, so we're plugging in a for x cubed, so I get a negative 2/3 times a cubed plus a times, that's going to be a squared. A times a squared gives me a cubed. Now these 2's are going to cancel, so I'm just left with a times a squared, which is a cubed. And again, when I plug 0 in for x into that expression, everything goes to 0, so it's just going to be minus 0. Combining those two terms, I end up with a cubed over 3. So what I've just found was this blue region here. That's the area between the top of the curve, the parabola, and the line where we're trying to find the slope of. Now, remember that shaded region in blue is equal to half of the shaded region, the region that we shaded in green, okay, which is the area that we have up here. So this value here has to be equal, this value here has to be equal to half of the value up here. So that's the next thing that we're going to do. We're going to set those two equations equal to each other, and that's going to allow us to find A. So here we have the area of the green region, half of the area of the green region, which would be 343 over 24 times 1/2. That gives us 343 over 24, and that's equal to A cubed over 3. Using cross multiplication, this should be a 48. Using cross multiplication, 48 A cubed is equal to 3 times 343, which is 1029. And we're going to divide both sides by 48. So A cubed is equal to 1029 divided by 48. Of course, A is going to be the cube root of this, and that value is going to be approximately, let me make it an approximation, 2.777951841. Notice I didn't round. In this problem, they don't ask us to round any digits. So, to make sure you get the answer correctly, I would recommend that you don't round unless they specifically ask you to round. Now, we're almost done. Remember, our goal is to find the slope of the line, which is represented by m equals 7 minus 2a. Now that we know what a is, we know that the slope of the line is equal to 7 minus 2 times this value that we just got, 2.777, and so forth. Again, please don't round. And when you're done, you should end up getting 1.444096,318. Now, your problem will probably have different values, but you should be able to work the problem in a similar fashion. I hope this helps. Let me know if you have questions.